Hi there, folks. As we're talking about electrochemistry, we're talking about spontaneous and non-spontaneous reactions. Now, what I'm going to demo here is a lab that we would normally be doing in session. However, I'm going to do it here for you to help you understand how to determine a spontaneous and non-spontaneous reaction and how to compare those to what is on the table of values at the end of our textbook. Okay, so what I have here is I have 5 different metals: magnesium, copper, lead, zinc, and some silver. And at the top, we've got different nitrate solutions. So as you remember, nitrates are fully soluble, so we are looking at these different metal ions in solution. All the ions we're going to use match the different metals that we're using as well. Okay, and so if we look inside each of these beakers, we're going to see how each of these metals here, copper, lead, zinc, and silver, is going to react to this magnesium ion. And very similarly as we go across. Okay, and so we can see that inside these beakers we have just pure metal. There's the magnesium, the copper, lead, zinc, and then we've got some silver wire down here at the bottom. Okay, I'm going to take each of these ionic solutions and pour them into these, and we will start to see some reactions happening and some not having reactions. This is going to help you with that spontaneous and non-spontaneous and how to use that chart. Okay, I've now added the appropriate ionic solutions to each of these beakers. Okay, so all silver, all zinc, all lead, copper, and magnesium. Okay, now in order to go from a metal, the pure metal, or even look up here, the magnesium pure metal to the magnesium ion, okay, we're going from a 0 charge to a 2+ charge. So to go from a metal to the ion means that we're being oxidized. Whereas if we're going from the ion in solution to the metal, we're being reduced. Okay, so the next question is, well, how would we tell that this is happening? Okay, well, if we look down at let's take the magnesium metal. Okay, as I go across here, the copper solution was blue, and we can see that we're starting to get some metal forming on the piece of magnesium that's in here. Okay, we notice that happening on the lead, the part that's been submerged. We can see that black forming. See a little bit on the zinc, but not really. Okay, a little bit. And then when in the silver solution, we see this bubbles kind of forming on the outside. That, if I can come down here, that is producing pure silver on the piece of magnesium that's in that solution. Okay, so so what we notice here is magnesium in every single one of these solutions is being oxidized to some level or another. Okay, now on the opposite end of that, if we look at the silver metal, in each one of these beakers where I've put solution, okay, and you can kind of see it sideways, so you can see that solution's in all of these. Okay, not one of these from the silver is being oxidized. Okay, so silver metal to go to an ionic solution doesn't happen all that easily, at least not with the combinations that we have here. However, if we look at the silver solution, there it is with magnesium. Here it is with the copper. You can just barely see that one piece of copper inside there. Here it is with the lead, and here it is with the zinc. Okay, and if we come sideways here, we can notice that all these pieces of metal that were put in here have silver growing on the outside. And growing is probably not the right word, but we do see these silver crystals and these silver metal being formed out of that solution. Okay, so in that sense, it's really easy for the silver to be reduced, okay, as it goes from the metal, or from the ion, the +1 charge, to forming metal on there. So it's really easy for the silver to be reduced. However, And this is why we use things like silver and gold for electronics, is because they don't oxidize very well, right? We see this silver metal not changing in any of these, okay? So silver being put into these solutions is not resulting in any spontaneous reaction. However, all these different metals put into the silver is resulting, okay, in that metal being oxidized and forming, or in the silver being reduced to form on the outside. Okay. Now, if we look down, I've shown you two extremes. We've shown you the silver where it is all the metals are reacting. I've shown you this is the magnesium and it's not reacting, or the magnesium solution is not reacting any of the metals that we've put in here. And if we follow that magnesium metal along, we see that it is oxidizing in every single one of these beakers, and to a different degree in all of them, okay? Now, similarly, if we look at the copper metal, this is the magnesium solution, the lead solution, and the zinc solution. It is not reacting with any of those. However, when we get over here to the silver, we see that it is reacting. Or if we look at the copper solution, we see magnesium is reacting. Hard to tell in this one, but the lead is reacting. If I kind of lift that up, we can kind of see that's a little bit changed inside there. Okay. We have the zinc, which we can definitely see has changed color. And then we see no reaction with the silver. Okay, so based on those observations, we would say silver, okay, the solution is easy to reduce, whereas the metal is not easy to oxidize. Copper would be the next level of that situation, where the only one it's not reacting with is the silver metal. Okay. If we're looking at lead, the lead solution, we've got magnesium, we see a reaction. Copper, we see no reaction. Zinc, we see a reaction happening, and then again, nothing in the silver. When we look at the zinc solution, we see that the only one that is oxidizing is the magnesium metal. Copper is unchanged, lead is unchanged, and silver is unchanged. Now, I encourage you to take a look at your chart, your strengths of the oxidations and reductions. Okay, that last table on page 336. And hopefully this helps you understand a little bit about how they're organized and how to undergo these reactions and to predict whether we have spontaneous or non-spontaneous reactions. Okay, and just a big overview of the whole situation so you can see. Hope that helps. Talk to you guys soon.